I'm here at ESA S-Tech, inside the Erasmus building, standing in front of a full-scale model of the ExoMars Rover that is due to launch in 2028 with Jorge Vago, the project scientist. We've been having a wonderful discussion at his office about the possibilities that the ExoMars Rover is offering and what we hope will bring some potential closure to whether or not Mars has life or ever had life. What excites you most about the rover mission, Jorge?
Well, three things really. One is that for the first time we're going to be able to drill deep in the subsurface, down to 2 meters. And this will give us access to material that may have preserved chemical clues for the possible presence of past life on Mars. That's number one. Number two is we have new instruments to look at organic molecules. And number three, this rover will go back in time to 4 billion years ago for the first time, to the time when Mars was more like Earth, had large bodies of water, running rivers, and hopefully that will give us the best chance possible to establish if indeed there was life on Mars once or not.
And what's special about the MoMA spectrometer?
MoMA is two instruments in one. One works more like the usual instruments we have used for organic molecule analysis on Mars on past missions, so with little ovens and columns that separate organic molecules before the detection. But we also have a new way to look for organic molecules with a UV laser. And this is very important because NASA missions like Curiosity and Phoenix showed that the surface of Mars is full of this pesky oxidant called perchlorate that can destroy the biosignatures that we would like to study. So this new way of extracting organic molecules that MoMA carries will hopefully go around this obstacle and give us very interesting new results.
And even if we detect signs of past life, and you said if it's extant or present life, we would be kind of bombarded with signals of present life, which would make it pretty clear that what we were seeing was present life. But even then, you say it might take a sample return mission to convince the research public, the researchers?
Well, I think that if we're talking about past life on Mars, probably its clues will be difficult to decipher. And so we can do much, much better in terms of analysis and confirmation with samples on Earth than we would even with an advanced mission like ExoMars. So yes, if we find something that is suggestive of the presence of life on Mars, I think scientists will want to have samples that they can study in their laboratories.
Then that would require a follow-on mission.
That would require another Mars sample return mission, one focusing on recovering samples like the ones that we would study with ExoMars, so deep samples.
Deep samples. And this is the big difference. You're going up to 6 feet or 2 meters below the surface. That's a big difference with this one compared to previous rover missions.
Correct. The deepest that anybody has dug on Mars until now is in the order of 10 to 15 centimeters. So this ability to go down 6 feet of 2 meters, as you put it, Bruce, is super important from the point of view of understanding the organic chemistry of Mars.
So let's, we don't get a chance to see a full-scale rover, face-to-face very often. Let's look at, you're using actually solar panels on this mission. Let's come back and tell us about this is a very cool looking rover to begin with, which has the design somewhat of a beetle, of an insect beetle, you said. Is that correct?
Well, the original design was a bit like that. What distinguishes the rover from all others is this big black box. That's the subsurface drill.
This drill here. This is the drill.
Yeah, That's a drill.
Okay.
And this is about 3 feet in length. And it's like a mini oil platform. You have to assemble 4 rods in order to reach the full depth of 2 meters. And once the sample is recovered, which is the size of my pinky, the whole box moves up and rotates, and there's a little hand that comes out here through this window, and the sample is collected there and then ingested and processed, ground up, and then analyzed inside the analytical laboratory.
Okay. And the solar panels, the solar technology is definitely improved. Let me back up a little bit just to get kind of an overview of this thing. It's like the size of a golf cart, I would say. What would you compare it to? The mast is a navigational mast. Is that the mast at top is a navigational mast?
Yeah, there's 2 navigation cameras there and 2 here. And these are the panoramic cameras that give you stereoscopic vision as a human eye. And that's a high resolution camera, which is like a teleobjective. And below it, co-registered or aligned, is an infrared spectrometer. Because everything on Mars is brown, and so it's very useful to be able to tell what the mineralogy of rocks is before you commit to go there.
Okay.